します。Today's my presentation title is Hysteresis of phytoplankton communities over Subpolar North Atlantic to shoot frozen. This video shows the temporal changes in chlorophyll concentration, and which is the most representative variables for my main research area. The ocean has a crucial role in regulating Earth's climate by absorbing the atmospheric CO2, and then the biological process cannot be negligible. The contribution cannot be negligible. In this biological process, the marine phytoplankton is the most key element, and then they are sequestering the dissolved inorganic carbon as a particulate organic carbon to the deep ocean. So we called it the biological carbon pump, and commonly, if we want to identify the magnitude of biological carbon pump, we calculated the downward particulate organic carbon flux. However, under the global warming, the ocean is getting stratified, and it makes weaker mixing, resulting in the lower nutrient flux to the surface layer. Then, under the lower nutrient marine environment, the smaller phytoplankton is more competitive because their higher surface area to volume ratio. So it means global warming makes weakening of the biological carbon pump. Because smaller phytoplankton has a smaller cell size, so they have lower efficiency of the VOC flux. So as Professor Sunil mentioned before, the Earth's climate system cannot be fully recovered even if we succeed to the carbon neutralization. So especially the research target area, the Subpolar North Atlantic region, the most representative physical feature, the AMA, has a delayed decline response. So we thought this delayed response of the AMA strength can affect the phytoplankton community shift under the negative CO2 emission. So to identify the phytoplankton community shift under the negative CO2 emission, we used shift negative emission experiment conducted by the Yonsei University. This experiment was designed by increasing the CO2 emission according to the SSP5 scenario until 2050, and with same magnitude decreasing until the atmospheric CO2 concentration reaches to the initial condition. After that, the CO2 emission reaches to zero. This experiment is based on the CO2 emission-driven experiment and of the CSM2 Earth system model. So in this experiment, this CSM2 provides three types of plankton functional types, such as diatom, diazotrophs, and small phytoplankton. This is the result. To identify the phytoplankton community shift under the negative CO2 emission, we compared like same CO2 level 2 periods, climb cruise period and CO2 down period. So to briefly say, the BC index is approaches to 1 if two groups are definitely changing. Also, if the BC index approaches to 0 if two groups are not changing. So in this figure, you can see there are two substantial shift upward regions. The one is Subpolar North Atlantic, and second one is Southern Ocean frontal zone. In the case of Southern Ocean frontal zone, I'll present later if we have next seminar like this. So please come to next seminar if you want to see this figure. So today I'm going to talk about the SPNA region. So if you look at the time series of the phytoplankton functional types in this region, there are large variations for all the PFTs. As we can see, there are a large decrease in diatom, while the large increase in small phytoplankton. Also, the diazotroph has a lower concentration, but it has decreasing trend according to diatom. However, it has overshooting pattern during the Listerine period. And we can think these large variations in phytoplankton functional types will be related to the nutrient changes, because nutrient is the most common driving factors for the phytoplankton growth. So if we see the two nutrients time series, which is the most important nutrients in this region, both nutrients are decreasing over time. And also, the nitrate is the most important nutrient for phytoplankton growth commonly. And then the silicate is well-known most important nutrients from previous studies. So maybe these both nutrients are decreasing. The main reason will be due to the delayed decline in AMAC strength. So as we can see in this figure, both nutrients are decreasing following the AMAC weakening. So main reason of the decreasing nutrients is gonna be related to the AMAC strength. However, we can see there are distinct features, such as nitrate is decreasing until the end of the ramp down period. However, the silicate is decreasing until 2000, about 80 or 90, and then there is no variations more. So we can think these different responses of nutrients can make nutrient limitation shift of the phytoplankton. To briefly explain the nutrient limitation, we can see in this figure, the nutrient limitation refers to the growth limitation of organism due to the nutrient deficiency. Like this figure, if the deficient nutrient will be supplied more, then the organism's growth can be promoted well. So if we draw the diatom nutrient limitation distribution between two periods, we can see, except for the northern part, the most region, nutrient limitation shifts to the N limitation from the SI dominant limitation. So from the time series of nutrient limitation, you can see the decrease in the limitation shifts to the N from the SI about around this period. So diatom is decreasing until the end of the ramp down as following the limiting factor, limiting nutrients. And then we also need to check about why do nutrients respond differently. We think these are related to this is due to the nutrient utilization by the diverging responses of PFTs. This is for better understanding, we brought the simple diagram. You can see this is during the climatic period, the nitrate is consumed by both diatom and small phytoplankton. However, the silicate is consumed only from the diatom. So as time goes on, the AMAC is weakening and there is a large decrease in diatom. So silicate consumption rate is largely decreased. So this can be compensated with the weakening of the AMAC transport. However, the consumption rate of nitrate is increasing due to the large increase in small phytoplankton. So these two different responses to nutrients can make a faster decrease in nitrate compared to silicate. So as the AMAC intensifies again, the nutrient entropic dynamics can recover and the nutrient limitation will recover to initial condition. Lastly, as I mentioned in the introduction part, we can expect the smaller phytoplankton dominant community shift can impact on the POC export, such as the biological carbon pump. So this is the global POC flux and this is the SPNA region's POC flux. During the climatic period, the SPNA region was stronger than the global average POC flux. However, after the negative shock emission, the SPNA Purge flux is weaker and weaker, and then finally weaker than the global average. So it means that the SPNA region is presently known for its strong biological carbon pump region. However, it may lose its prestige under CO2 mitigation scenarios. This is my research summary. We found a strong hysteresis of phytoplankton community in the SPNA region. Mainly, it is due to the weakening of the AMAX strength and less nutrient transport. In addition, due to the different nutrient responses by the PFT responses, so there is a nutrient shift is occurred. So diatom is decreasing persistently, so it makes the Earth's, it can suppress the Earth's carbon uptake capacity. So these results have alarmed us about, even if we succeed to carbon neutralization, if the global warming accelerates again, then we may experience a further severe global warming due to the suppressed Earth's biological carbon uptake capacity. Thank you.